So, I don't even call it spring break. I call it spring weekend.
Yeah.
I'm like, dude, and it's like, I want to get everyone to understand whenever we vote for calendars, they all look and say, it's a later start date, we're picking this one. I'm like, no, look at the one that gives us a full week break. We picked it this year. At least we voted for it anyway. We'll see. So, this word has probably terrified you. This word has probably made you cry at night.
Makes me cry during the day.
Oh, okay, that too. Today, I have great news.
You're going to give us
Be
bones.
careful what you say.
I could really
No.
use some
I never believed your great news.
I got great news.
I know what the news is.
It'd be like quiz tomorrow.
It's coming back.
Probably use it for friends.
We are done with
Oh, man. Thomas, you were close.
Lovely.
We're going to add more. So in this, so you guys can get an understanding of this, they go by another name. In this, our polyatomic ions, you can really focus down and into a large group of them. And this large group we call Oxyanion. So today, I want to cover Oxyanion Nomenclature. There's only one way I know how to do that. Don't try and draw as I'm drawing, especially if you're drawing with pen. I will look at you and tell you when I am finished. I am making a box. This box will be your best friend. This box could also be the end of you, but you know, that's besides the point.
Can we draw a box?
Sure, you draw a big box. It's got to be big. Alright, that's what you're looking to draw right now. As my physics classes pointed out to me, I could not draw a straight line, so if you feel like it, make sure to make yours straight. I could care less. I feel like I got Miss Amy Powell in my physics class with me. My God, you suck at a straight line. Whenever you had to like solve equations by graphing, I always got in trouble. I always got the answer right, but then she would not give me points because she's like, you didn't use a straight edge. Your line is not straight, it's crooked, it's jagged. Okay, so today the point of this is to help you. Okay, all jokes aside, this is not to make you hate your life. This is actually to help you. And this is to give you a systematic way of coming up with these names. In this, I promise you, before you start yelling at me and say, you should have gave us that sooner. No, you didn't want me to give you this sooner. This is literally going to open our world up to polyatomic nomenclature. I have had you into a small little teeny tiny box. Today I get to expand this box wide open and take it as far as I like. So within this second box is the most important one. This is the one that is most common. This is what we would consider our root ion. Most common. Now in this is the one that you have to memorize. This is how we're going to build these things. The key to this is memorizing one, then memorizing the pattern. So if you can memorize this one, we're going to build off of it. So in this, you should be used to hearing something like this. It'll go by the name of it, be root. And the ending is 8. So an example of this that you guys are familiar with. Here's the root. Here's the ending. Chlorate. Within chlorate, you should know the chemical formula. I need you all to calm down. Y'all are so loud. Just let's mumble it together, guys. I can't figure out what y'all are saying with it. Because you totally got memory, right? I don't feel like disappointment this morning. I'll just write it. ClO3 negative. Does that negative matter?
Yeah.
Yes. As many of you are figuring out. This is the root. This is the one that we memorize. I know chlorate, and now I'm going to build everything off of chlorate. So, first thing is if we drop down. Every one of these are going to have the root in it. But we change things as we go. In this, everything is dependent on how many oxygens there are, whether we're gaining them or losing them in reference to this root ion. So whenever we look at it, let's say for example, we come here and we go below. So we have one less oxygen. Then the root. Whenever you lose an oxygen from the root, that's where the ending will change to ite. So we have root ite. So in this, I have one less oxygen than rootate. So rootite is ClO2. So whenever you look at this, like I said before, we're going to keep this root on all of them. But we change the ending, so we have chlorite. Let's say, for example, we add one. And this is the point I'm going to stress to you. The middle two, rootate and rootite. Okay, you're going to change the ending. If you gain an oxygen to the root, you're going to add a prefix to it. So, let's say I have added an oxygen. Added an oxygen. Words are hard. So I now have 4 oxygens. Notice something with the charge. The charge is staying the same. So in this, I've added an oxygen to it. In this, that's one more than the root. If you do that, you're going to keep the ending the same. So ATE stays. But we add a prefix. This is where, and I think you guys, I think I gave you this one. You get per at the beginning. P-E-R. So per root 8. So we would have perchlorate. How y'all doing?
Okay.
What? This is the system that help you memorize. Because we're going to start using them in our nomenclature. Today we take these and expand them into all the nomenclature you've learned. Because tomorrow when you come in here, we're going to expand off these and do acids.
We're doing acid.
Acid nomenclature.
As long as you said a minute ago.
Here, Jesus. So then we come down here at the bottom. Now this is the key. The last one. This is where you have 2 fewer oxygens than the root. The key to this is it's 2 less oxygens than root. This is the root, okay? You're not going to take 2 off this. Remember, everything's based off of the root. So I'm going to take 2 oxygens off the root, so I have ClO negative. Whenever you do this, your ending is going to stay the same as the one above. So ite. But in this, we're going to change, and yet again, we're going to add another prefix. This is where the prefix hypo comes in. So hyporudite. Or hypochlorite. This is the important aspect of this. I need you to get this, because what's going to happen tomorrow when we come in and we do oxyanion acid nomenclature, the 8s and the ites are what's going to change. We'll keep these prefixes. This is where you have to get the prefix right, but then I need you to get that the 8s and the ites are what's going to change for us. Yes.
Apparently I did the calendar thing wrong yesterday, so what calendar would you like, 1 or 2?
2.
Thank you, sir.
How did we do it wrong? If she would have done that, she would have asked us for Teacher of the Year too. So, you've got to get this down. This is a system to help you with this. Okay, this is the thing. You're not having to memorize perchlorate, chlorate, chloride, hypochlorite. You just have to memorize chlorate. And then you can build the other 3 off of it. Make sense?
No.
Kinda. I think I've got it.
Is it gonna be like more or less like, are we gonna get into 3 lots or 2 more?
Pretty much. Like I could take any polyatomic ion I've gave you, and now I can change the number of oxygens. So I can take the root, and I can break it completely down. So,
Are we gonna get a list of prefixes?
no, that's it.
So where did you get these prefixes?
Do what?
Like, why are these different than the other ones?
Which prefixes are we speaking of?
Like,
They are in there, but now you know where they're coming from and why we have them. That's the key. Is I'm trying to make it less for you to have to memorize, because you have to memorize so much now. If you can ever find a way to where you have to memorize less, it's better for you. Like, I can't get away from it. This is memorization, but I like a system. Like when we totally finish the whole thing, all of nomenclature, I literally draw out a map that is my mental process to figuring out which naming rules to use. Because in the end, I want to say you have 6 different scenarios you have to figure out which one of those 6 scenarios you need to apply. And it matters. Okay, so in this should look familiar to you. What is that?
Sulfate.
Sulfate. Was that on your polyatomic ion sheet? No. But guess what? It's fair game. What is that? Persulfate. Now, here's where things get tricky, and this is why I held this off until your second nomenclature quiz, which you'll be having once we come back from our little break.
Speaking of second nomenclature quiz, can we see how we did on the first one?
Sure. Let me do this and I'll give them to you. So in this is how things can get cruel. So you remember how we dealt with those charges? So let's say, for example, I gave you, I don't know, sodium oxide. So I gave you sodium oxide. You had sodium, it's a positive charge. Oxygen was a 2 negative charge. So that 2 negative came down, and that 1 came down to give you Na2O. Same thing's going to apply here, but the difference is you have a polyatomic ion. This is why I stress you have to memorize and know the charge of those polyatomic ions. Because whenever it comes into play to this, if you do not know the charge, you're going to get the chemical formula wrong. You get the chemical formula wrong, you are wrong, because then you're not going to get the chemical equation right, you're not going to get your chemical reaction right, you're not going to get your stoichiometry right. So in this case, let's say I had sodium sulfate. So I have sodium, the plus charge. In this, the 2 comes down for the sodium, the 1 comes down for the sulfate. So we have Na2SO4. I want to stress this to you. You're still going to follow your ionic naming rules, but you will name the polyatomic ion. So following those ionic naming rules, we would go with sodium, because we're just naming it strictly off of the monatomic ion that it is. But then here, you're not going to name this sulfur tetraoxide. No. This is the dead giveaway. How many elements do you have present?
3.
There's 3. If there is 3, I'm telling you right now, you should set an alarm in your head. 3 means polyatomic.
Donnie Porter, come to the office, please. Donnie Porter.
Well, I should really do 3 or more. For this class. Later on in chemistry, you'll get in other chemistry classes and you'll learn different nomenclature rules that takes you outside of that. But for right now, where we're sitting, where we're at, 3 or more means polyatomic. Find the polyatomic. So in this case, we found it. Then you just literally name that polyatomic. Sodium sulfate. Here's the key, and this is why things are very cruel. And I know you're going to think this is unfair, but you'll be okay. Is there a charge here? Yes. But it's hidden. How am I hiding it? With the positive charges coming from the sodium, I even it out to where it's nice and neat. You won't see the charge, so you won't automatically catch polyatomic ion. I'm stressing to you right now how to tell if you have a polyatomic ion. Got it?
Yes.
Very nice. I just feel like everybody's just in such a great mood today.
I'm actually doing okay today.
Well, that's nice to hear.
We're almost halfway through the week.
It's also nice to hear. Okay, so let's say, for example,
Mr. Mayor, is there ever a time that you would use the Roman numerals for those?
no. Wait. Yes. I apologize. Yes, very good question. If I had a transition metal here, why? Because you would have to use Roman numerals to tell the charge on the transition metal. How are you going to figure out the charge on the transition metal? You're going to have to use the charge of the polyatomic ion. It's a great time to do this. Let's just do it. So let's say I give you copper 2 hypo nitrite. Did you have hyponitrite on your polyatomic ion list? No. But do you know what nitrate is? Yes. What is nitrate? NO3 negative. That's nitrate. So now to get to hyponitrite, I'm going from the root to the hyponitrite. It's 2 less oxygen. So NO negative. Now we can look over here. I have copper 2, so Cu2 plus. Now you're going to do the same thing, and I did this one on purpose. Because I seriously doubt you guys remember, at the very beginning I showed you a chemical formula that looked like this. So the 1 comes down for the copper, so Cu. But then I have the 2 comes down for the nitrate. This is where I stress to you, don't make the mistake. If you have a number that's coming down and you need multiple of that polyatomic ion, put it in parentheses. So I'll put parentheses NO in parentheses, and I'll put the number outside the parentheses. That is the proper chemical formula for copper 2 hyponitrite.
Now, why didn't we do a parenthesis 1? For the one going down to the copper.
Because copper's by itself.
So you don't need to.
This is if you need multiple of a polyatomic ion, because this is why. What if you just brought the 2 down? In this case, red means bad. Don't do what I do in red. So you got Cu comes down, 1. Then I have NO, and 2 comes down, right? So 2. That's not the same. If you look at this, you have 3 in here, right? So you have a polyatomic ion. Find the polyatomic ion. You're going to look here. NO2. You're then going to do your math and figure out that this is copper 1, you think. Because this right here, you only have 1 of it. Because it's a polyatomic ion, so this is NO2. So that's NO2 negative. which is nitrite. If you need multiple, you have to put parentheses around it. As soon as you put parentheses around this, it totally changes it. It's saying there's 2 hyponitrites. This is where it starts getting harder.
Can you do one where we don't know the charge of the deflog element?
I absolutely can. I'm going to save it for tomorrow, though, because you asked to see your quiz.
Do you,
So, more respect to that.
you put parentheses if the number's like 3 numbers bigger than 1?
Yes. If you need more than one of that polyatomic.